Things you're going to find in the specifications are quality of material, quantity of material, methods of construction, and the manner in which you're going to be doing the work. And these are going to be things that you won't necessarily find on the blueprints themselves. On the floor plans, you're going to find things like the location of the interior walls, stairways, and floor openings. You're going to find which way the door swings, where the outside walls are, and their dimensions. Those will all be found on the floor plans. There's three different types of framing you're going to see in the residential construction. We have platform framing, which is also called Western framing, and that's where we build a platform. The platform is constructed as an individual unit, and then the walls are built in place on top of the subfloor, then they're tilted into place. Once they're tilted into place, they're nailed to the subfloor. Then you have balloon framing, where the studs are going to run all the way from the foundation all the way up. Even if there's a second floor, they do not stop. They just keep going all the way up. And then lastly, we have post and beam, and that is going to be fewer but larger pieces. They're more widely spaced, but each member is bigger. You're going to see stuff like this if you go into like a Cabela's, you go inside and look around, you're going to see post and beam construction. In the top right here, we've got a typical cross-section of a basic floor frame. You've got your footing, your foundation wall, then you have, sometimes they do a termite shield, then there's the sill, and then you have the rim joist, the header joist, and floor joists, and then subfloor. And you can see how that all stacks up on top of the foundation. Take note, the sill is usually going to be a 2x8, and it needs to be treated when it comes in contact with the foundation, just like we have here. It's right next to the foundation. It's close to, even though it's not actually touching the foundation, because we're going to use sill sealer, it still needs to be treated. The siding is going to come down, and we're going to backfill, and it's going to be really close to the ground and groundwater, so from rain and things like that. So it needs to be treated. I want you to be aware of the fact that we have all these floor joists, and all the red indicate that those are rim joists. That makes up the rim joist, the whole system of rim joists there. And all the black ones here are just regular floor joists, but the very first and the very last are called end joist, and the one where all the floor joists butt into, that is called the header joist. So you have two header joists, two end joists, and that makes up the rim joist. When it comes to girders or beams, they can be made up of several things. You could have it be a steel I-beam, LVL, a solid piece of lumber like we saw in the Larry Hahn video. It could be a glue lam, which is going to be several boards all glued up together, like 2x6s laid flat, and they're all glued up together. That's a glue lam. Or built up, like you could have 3 2x10s all nailed together. That would be a built-up girder. As far as based on size, if we just had 8 inches or 9 inches that we had to play with, the strongest girder you could have is going to be steel based on size. But based on weight, if you wanted to get the lightest girder you can, you're going to use, and still be strong, you're going to use wood. So we've got the plan view, so this top-down view of the girder going into the foundation wall. And here's the section view of the girder going into the foundation wall in the beam pocket, okay? The girder pocket. So the pocket needs to be 1 inch wider than the beam, and there needs to be at least 4 inches of bearing of this beam in that foundation wall. And when you're going to have a splice in the girder, always try to position it over a column or a post. So when we're talking about the floor frame assembly, if possible, you would like to backfill after the floor frame has been built. A lot of construction crews, framers, will not build start to do the floor frame and the walls and the rafters until the house has been backfilled. It's a safety issue. But if you can have the floor frame assembly, when you backfill, it's going to help hold this foundation wall up. It'll help it withstand the lateral pressure of the backfill. Without it, you see here, if you backfill, there will be a tendency to have this foundation fail because of all the lateral pressure put on it. The bottom's locked in place by the slab, but the top is free to move in this situation. In this situation, you've got the floor framing assembly. Okay, also you want to check your foundation for square, and how you're going to do that is you're going to measure diagonally, and you should have the same measurements. Also, you need to check your sill plates once you have them on and bolted down. Check them for level. If they're not level, what you're going to have is a floor that's not level, and then subsequently walls and all that. Everything else will be out of level. To check it for level, you want to use an 8-foot level, a transit level, or a builder's level. And when you are nailing your floor joist, you want to nail them in a certain way. And how that is, if we took a cross section right here, this is a section view, this is the sill plate, this is the header joist, this is the floor joist. You're going to nail through the header joist into the floor joist, and then you're going to toe nail the floor joist into the sill. Also, this is an elevation. We're looking at the side of the floor framing assembly. You're going to nail right through the header joist, and then diagonally toe nailing that floor joist into the sill. And that header joist needs to be nailed off every 6 inches with 8D nails. And that goes for when it's, at the end it's the header joist, and when it's down the sides it's the end joist. And they need to be nailed every 6 inches with 8D nails. When it comes to floor joists, you've got several options. You could just do plain old dimensional lumber. That's going to be the most cost-effective way to build your floor system. You've got 2x6s, 2x8s, 2x10s, 2x12s. The next step up would be an I-joist. They're man-made, so they're going to be able to come in very long lengths. With dimensional lumber, you're restricted to anywhere from 14 to 18 feet long. These you can have them span all the way across the house, but you might have to put some intermediate supports like a girder or a beam. But it would be one continuous board, so that as you're nailing off your subfloor, you just nail straight through. The flanges are the top and the bottom, and the web is the middle. The web's almost always going to be OSB. The flanges are made of several different things like LSL, LVL, or even solid lumber. The next and the probably the nicest of all these are going to be trussed floor joists, and they can be either made out of wood, or they can have like a top and bottom flange made out of wood with metal webbing, or it could be all metal. So the advantage of a metal truss is it's gonna have larger openings because it's smaller pieces of metal versus a big 2x4 running crisscross through here. Smaller pieces of metal, so it creates larger openings. It can do even greater spans, and it's stronger than lumber. It is less common. It's probably the least common out of all these things. Sometimes an architect will want to hang the floor assembly out beyond what's supporting it below, and if that's the case, what you have is a cantilevered floor. Now, here's some, around a floor opening, here's some terminology. We have a trimmer joist, which are the joists that are off layout, but they are going to be helping to form the floor opening. So these are the trimmer joists. They're still full length, but they're off layout. And then you have tail joists. They're shortened joists that are parallel to all the other common joists. And when you're going to build a floor opening, there's kind of a set procedure that you would go through. You would put in the inside trimmer joist first, and you'd run them through. Then you would put the this horizontal joist here. You could maybe call it like a header joist, and I would put the furthest outside, the closest to the tail joist, so that when you're putting up the tail joist, you can just nail right through that header joist into the tail joist, and do that on both ends. Then you would double up this header joist, and that way you still have access to nail in from both sides through that trimmer joist into this header joist. Then all you do is double up both the trimmer joist and you're done, except for you'd probably put on joist hangers in all these locations where the trimmer joist hit that, and where these here, right here, those would all be joist hangered. Then when you're ready to put subfloor on, you're going to chalk a line 4 feet away from the header joist, and when you put down your plywood, you follow that line. It'll be nice and straight. And lastly, when you put on your cross bridging, you're going to nail the tops, leave the bottoms until after we have put the subfloor down. Once the subfloor is down, you nail them from below. That way, if you have to move or adjust these floor joists as you're putting down subfloor to keep them on layout, because they may not have stayed straight, and if they're a little bit off and you nail them down, they're not going to move. So you want to leave them loose, put down your subfloor, and then nail from below and lock them in place. When you have your floor joists running in one direction, in both scenarios here, our floor joists are running in the same direction, and we're having a load-bearing wall, in this case running parallel with our floor joist. In that case, you need to double a floor joist underneath that floor, or put a double floor joist off layout underneath that wall to support the load. When you have a load-bearing wall running perpendicular to your floor joist, you would simply add a girder underneath it running in the same direction as the wall. A material takeoff is a list of all the different types and dimensions of the material we're going to be using. And to do that, we have to take a set of drawings and look at them and be able to estimate all the different types of material we need. So if we're going to look at this, this is showing the foundation and floor joist. It looks like we have a girder with some piers under here to help support the load of these beams. So I want to know, how much sill plate do we need? So to calculate sill plate, we're just going to order it in linear feet. So I need to know how far it is all the way around this building. So we have 80 here and 80 here, which is 160. And then we have 30 here and 30 here, which is 60. And we add those together, 220. So for sill, we're going to need 220 linear feet of sill. For the girder, I need 80 feet. I need 80 feet in length of girder, but it tells us here on the prints it's made up of 3 2x10s. So I would take 80 times 3. $240. So I need 240 linear feet of 2x10s. This would be 2x10s. This would be 2x8s, and that is, they're pressure treated. Now we want to calculate how many pieces of subfloor we need to cover the floor framing assembly. We know that one piece of subfloor is 4 foot by 8 foot, so 4 times 8 is 32. So one sheet is going to cover 32 square feet. So I just have to know how many square feet this whole floor framing assembly is and divide it by 32. So I'm going to take 80 times 30. I'm going to find the area, and this is going to be 8 times 3 is 24, and we just add our 2 zeros. It's 2,400. So I know it's 2,400. And I'm going to grab my trusty calculator. I'm going to take 2400 divide by 32, and that's going to be 75 pieces. Now, in reality, I'm not going to buy 75 pieces of subfloor. I will probably add an extra 10%. There's probably going to be a stair hole or something like that. And the easy trick to do on that is just take our number times it by 1.1, and that will add in the 75 pieces plus the 10%. And that's 82.5 And that's how many sheets of subfloor I would buy. Can't buy half a sheet, so it's going to be 83. In commercial construction, they're going to use like a pan or a solid concrete floor assembly, whether it's concrete that's been precast somewhere else and it's already cured and everything, and they bring it and they drop it in place, or they form it on site and then pour it right in place, right where it's supposed to be. So the long pan and dome pan system, that's used when concrete voids are needed in the underside of slabs with a concrete joist system. So that's where the bottoms have these little voids in them. Also, modular panel and pedestals are used where large amounts of cabling is required.